Simple curves are polynomials of different degrees or orders. The degree is the integer of the highest exponent in the expression. For example, a straight line is a first order, degree 1 polynomial of the form ax plus b, or more explicitly a times x to the first power, that's where the 1 comes in, plus b. A quadratic is a second order, or degree 2 polynomial of the form ax squared plus bx plus c. A cubic, degree 3, is of the form ax cubed plus bx squared plus cx plus d, and so forth. In MATLAB, a polynomial is represented by a row vector of the coefficients. For example, a second order or a quadratic polynomial would be represented by a row vector with the length of 3. In other words, the coefficients a, b, c in the form ax squared plus bx plus c. MATLAB has some polynomial functions. We have the roots function and we have the polyval function. So the roots function, you pass to it one of these row vectors that represents the polynomial, and it'll set that equal to 0 and solve for the roots of the equation. The polyval function, we pass to it two arguments. The first is, again, one of these row vectors that represents the polynomial, p, and the second is x, where x could be a scalar or x could be a vector. So for example, here p is 3 minus 2, 1. So in other words, that represents the polynomial 3 times x squared minus 2 times x plus 1. So again, we have in there the coefficients, the 3, negative 2, and 1. So that's our row vector p. We pass that to polyval with a value of 3, for example, and we're plugging in 3 times 3 squared minus 2 times 3 plus 1, or 22 as a result. Or you could pass to the polyval function, again, your row vector p representing the polynomial, and in this case a vector. So we're evaluating the polynomial at x equals 1, 2, 3, 4, and 5. In many cases, we have data in the form of x and y points in two-dimensional space that's sampled either in time, for example, every second or every hour, or in space, for example, every inch or every kilometer. Curve fitting is finding a curve that best fits the data points in order to fill in the missing data from the sampling. There are lots of different kinds of curves that you could fit to data points, and MATLAB has several curve fitting functions, and it also has a more sophisticated curve fitting toolbox that has even more functions. We're going to keep it simple and just fit simple polynomial curves to our data points. And to do that, we're going to use the function polyfit, fits a polynomial curve through the points. You pass to it three arguments. The first are the x and y vectors that represent your data points, and the third argument is the degree or the order of the polynomial that you want to fit through the data points. So if I have my x and y vectors and I say polyfit x comma y comma 2, then I want to fit a second order, a degree 2 polynomial through my data points. So the polyfit function is going to come up with the coefficients of the polynomial that best does that. Once we have created our polynomial curve that fits through the data points, we can use that to estimate values other than at the sampled data values. Interpolation is estimating the values in between the recorded data points. So let's say, for example, we've recorded something every hour. Interpolation might be estimating what happened at the half hour. Extrapolation is estimating outside of the bounds of the recorded data. So for example, in time, before you started sampling or after you finished sampling. So both of these, interpolation and extrapolation, can be accomplished using polyval. So you evaluate your polynomial that you found at certain data points. It's very important to understand that the better the curve fit, the more exact these interpolated and extrapolated values will be. Question 1. What is a danger of extrapolation, going beyond the bounds of your data values? So let's say, for example, we have some points. So we have some points, some crude points, and we have fit a curve through these data points, and now we're extrapolating. So this is my first point, this is my last point. We want to extrapolate what happened before the data began or after we stopped collecting, so after this point in time. What would be the danger of that extrapolation?